What's up, guys? Today we're doing a video on measures of spread. Measures of spread are numbers that describe how spread out a data set is. And the two that we're going to look at today are variance and standard deviation. Both of them use the symbol sigma. This is the lowercase Greek letter sigma. And variance is sigma squared. Standard deviation is sigma. So variance, this is the definition. It's the average of the squares of the deviations from the mean. And you don't need to think too much about this because the calculator is going to tell us how to get this. Now in class, we are going to do an activity where we're going to go through and we're actually going to calculate variance by hand. And it'll give you some understanding of where this comes from. I think it's important that you know where it comes from. But most of the time in class, we're going to be calculating this with the calculator. And the standard deviation is simply the square root of the variance. Okay. Now the standard deviation is the one that we're going to use the most in class. It's the one that people use the most when they talk about statistics. They describe the standard deviation. It's used all throughout statistics and science and everywhere else. This is the statistic that people are going to use. But it does come from variance. And so when you're calculating these by hand, you have to find the variance and then take the square root to get the standard deviation. As it turns out in the calculator is only going to tell us the standard deviation. So if we want the variance, we have to square it to get the variance. And so we'll just go ahead and jump in with a couple examples here. I've got 10 numbers arranged here on this first example, and I'm going to put them in my calculator. Okay, and so I'm going to go to data, and I notice I've already got some data in there from a previous example, so I'm just going to delete it all out. And I'm going to type all of these numbers in the calculator. Okay, I'm going to go back through and make sure I got them all right. 3, 8, 12, 12, 13, 26, 42, 45, 53, 67. Notice it says L1 in parentheses, it says 10. That means I entered 10 data points. You can use that to make sure you've got the right amount in there. Okay, so now I'm going to hit second data for stat, just like we did on the previous lesson. One variable stats, because it's one variable. Data is an L1. The frequency is 1 because it did not use the frequency table. All right, let's talk about what some of these numbers mean. We scrolled to the bottom before and used the 5-number summary. Let's talk about some of these other things. N is the number of data points I entered. Again, check to make sure that that number is the correct number. We entered 10 data points, so this should be 10. Okay, now, both of these numbers here, Sx and sigma x, both of these are standard deviation. The letter S, X, is the sample standard deviation. Sigma X is the population standard deviation. And in order to know which one of these to use, it comes down to context. Since there's no context behind these, I'm just going to assume that these are all of the data points I'm looking at and use the population. So unless you know otherwise, we're generally going to use the population standard deviation. Okay. When you would use the sample would be if you took a sample from a larger population. So if I were to randomly select 100 students at Hiram High School and measure their height, that would be a sample from a larger population. And for the standard deviation in that case, I would use Sx. For our purposes, it's not that big of a distinction. We're going to pretty much mostly use the population standard deviation, which is sigma x. So in this case, that is 20.9, rounded to 20.97. And so to find the variance, I just need to square this number, okay? And one way we can do this, if you press enter, well, let's not do that. Hit second, quit first. Make sure you're back at the blank screen. Now, when you go into the stats, if you actually find a number that you want to work with, I can press enter and it will just type it on the screen for me. And then I can hit squared and it will actually find the square of the number for me. I'm going to hit the convert button here to get it as a decimal. 439.69. Okay, and if you didn't want to do all that, if you just wanted to type it, you could just say 20.97 squared. Okay, and again, 439 point, it's a little bit different, and that's only because the rounding. This was a rounded number. When I typed it from the calculator, it had all those extra digits, and so it's slightly different. Okay, but that's all you have to do. You just take this number and square it. That's the variance. Okay, so I want to look at this other data set, and then we're going to compare the variance and standard deviation and talk about what it means. Okay, so I'm going to go back into my data. I'm just going to delete them. It's just 10 numbers. Just press delete. Okay, I'm going to type these in. Now, I think I want to use this opportunity to go ahead and talk about the frequency table, because if you notice, these data repeat some. Okay, still wouldn't be a big deal just to type all 10 of them, but I want to use this as an opportunity to show you how the frequency table works. So instead of saying 15, 15, 16, 18, I'm going to say 15, and then over here to the side, I'm going to say how many of those there are. There's 2 of them. Then I'm going to say 16, and how many of those are there? There's 1. We've got 18, just 1 of those. Oops. Okay. Then I've got 19 and 21. There was 1 19, and there's 2 21s. 23. We've got 2 of those. And 24. And I've got 1 of those. Now this probably, again, isn't the best time to use it. You really want to use it when you've got a lot more repetition than that. But I wanted to show you how this works since we haven't really used it yet. So now I'm going to hit second stat. Still going to be 1 variable stats. 2 variable stats would be if we were comparing height and weight, or 2 different numbers. Even though I'm using 2 columns, this is still 1 variable stats. The difference now, though, is that my data is in L1, the frequency is in L2. Meaning we're telling the calculator that there's not just 1 of each of these things in L1, so that each of those things happens a different number of times, and that frequency is given by L2. Still, you need to check and make sure that n is 10, especially when you're using a frequency table, because sometimes you make a mistake on the frequency. It should still add up to 10, and it does. That tells me that it's correctly going through and applying those frequencies to the things in L1. So if I scroll down, the standard deviation in this case is 3.23. Okay, and I'm just going to go 3.23 squared, which is 10.43. So what do these numbers mean? Well, let's look at these data sets. Notice that this data set is much more spread out than this data set. These are much closer together. The mean of this one's probably somewhere around 19 or 20. The median's somewhere around the same. The middle number here is probably somewhere around the 30s. But the data is way more spread out. It goes all the way from 3 up to 67. These only go from 15 to 24. It's only got a 9-point spread. So the more spread out the data is, the bigger this number is going to be, and therefore the bigger this number is going to be also. The variance and standard deviation both get bigger the more spread out the data set is. So if you didn't even have the data, and all I told you was that the standard deviation for one was 20.97 and the standard deviation for the other was 3.23, you would know that this data set must be much tighter, much closer together, not as spread out. Less variance. And that's basically how we're going to use these when we answer word problems. They're going to ask you questions to describe the spread of the set. You would say that this is a much more spread data set than this. Or you could say that this data is more consistent. The data is much more consistent here than this data is. It's where it's more diverse.